Okay, so let's put this all together. Let's really think about the work that we've done so far and really how it's all leading up to our ability to be able to find exact values of specific trig functions. So when I do this, I really do think about a combination of both the unit circle and right triangles. So let me kind of run through what I think is important, and what we're trying to do is get to a place where we can find exact values. So what you're going to be asked to do will be to do something like find sine of 5 pi over 6, or find cosine of 14 pi over 3. And what we're going to talk through now is that process of finding those values. So as far as the unit circle goes, I think about the unit circle when we're really focused on the angles that are on the actual axes. So when we think about the unit circle, so I'm just going to draw a circle, I think about these angles. So 0, 90 degrees, or pi over 2 radians, 180 degrees, or pi radians. Oops, it'll be right here. 270 degrees, or 3 pi over 2 radians. And we'd be back to 360 degrees, which would be the same as 2 pi. So sure, when I'm looking at those angles, I think unit circle because it's easy to remember these points. Remember, if this is the unit circle, then this point would be 1, 0. This point would be 0, 1. This point would be negative 1, 0. And this point would be 0, negative 1. Remember, every point on the unit circle is cosine theta, sine theta. So for example, if I was looking for, what is the exact value of, let's say, sine of pi over 2. Well, then I would think, okay, here's pi over 2. Here's the associated point. I know that sine is the y-coordinate of that point, so sine of pi over 2 is equal to 1. What if I said, okay, what is tangent of 270 degrees? Okay, so I would be thinking about this point, and this would be the associated ordered pair, right? Remember that, so 0 for cosine of 270, negative 1 would be sine of 270. So tangent, I know, is the same as sine over cosine. So sine over cosine would be negative 1 over 0. Can't divide by 0, so this is actually undefined. And so it's also important to think about those quotient functions. And so by that, I mean it's important to remember that tangent is sine over cosine, that cotangent is cosine over sine, and that the reciprocal functions, that secant theta is, remember, the reciprocal of cosine, and that cosecant theta is the reciprocal of sine. So now what about when we're looking at angles? We're applying trig to angles that aren't on the axes. That's when I think about the triangles. So the special right triangles that we've talked about. So right, we have our 30 degree, 60 degree, 90 degree right triangle. And we also have our 45, 45, 90. And so what we want to remember is, so this would be 1, 2, square root of 3. The way I remember that is that I can remember that sine of 30 is 1/2. And that's an easy one to verify on a calculator as well. And so it's 1, 2, square root 3. And remember, Pythagorean theorem can always help you derive that if you forget. The 45, 45, 90, the legs are each 1, and the hypotenuse is the square root of 2. So it's also good to be able to go back and forth between radians and in degrees. So I also, without having to convert, remember that pi over 3 is the same as 60 degrees. Pi over 6 is the same as 30 degrees. And that pi over 4 is the same as 45 degrees. So those are always your reference angles too. So we can use our triangles and we can use them as reference angles by thinking about which functions are positive and which functions are negative in the various quadrants. So to keep the signs in mind, I always think, a lot of people teach all students take calculus. I always just think of the word cast, C-A-S-T. So this means that cosine and its reciprocal are positive in quadrant 4. All functions are positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2, and tangent and its reciprocal are positive in quadrant 3. Okay, so how do we put this all together? So let's go back to that sine of 5 pi over 6. Let me change colors so we can look at some examples and apply this. Okay, so let's go back to, we're going to find the value for sine of 5 pi over 6. So first thing, we can outline a couple of steps here. So first thing we want to do is plot the angle on the xy plane. Okay, so I'm going to draw my xy plane. We're working in radians, so this is 0, pi over 2, pi, and then 3 pi over 2, and then back to 2 pi. Okay, so 5 pi over 6. I focus on that denominator of 6. Okay, so I'm going to think of pi with the denominator of 6. So if I think of pi as 6 pi over 6, right, because 6 over 6 is just 1, then I can more clearly see that 5 pi over 6 would just be pi over 6 before 6 pi over 6. So this would be 5 pi over 6, and my reference angle would be pi over 6. Okay, so if this is 6 pi over 6, just before it, pi over 6 before it would be 5 pi over 6. So now if I want to think about the triangle in that quadrant, I'm just going to drop my altitude to my right angle right there. Pi over 6 is the same as 30 degrees. So then I will label my triangle accordingly. Opposite 30 degrees or pi over 6 is the 1. Hypotenuse is 2. So this leg would be the square root of 3. Also, think about where things are positive, right? So where we're going to get positive, where we're going to get negative values. If I think of my CAST, sine is positive in the second quadrant. So sine of 5 pi over 6 is the same as positive sine of the reference angle, which is pi over 6. So sine of pi over 6 is 1 over 2, opposite over hypotenuse. So sine of 5 pi over 6 is 1 over 2. So let's go back through our steps. So first we plotted the angle. Then we identify the reference angle. Oops, I'm spelling that wrong. Then we considered the signs, what's positive, what's negative. And then we used the tools that we had to find the exact value. So let's try another one. Okay, so let's take a look at cosecant of 14 pi over 3. Or actually, that's just cosine. Cosine of 14 pi over 3. Okay, so let's plot the angle. The first thing that I notice is that 14 pi over 3, so 3 goes into 14 more than 2 times, right? So this is going to be an angle that goes around more than once. And so if you think back to when we spent some time on the unit circle, it's helpful to think about the unit circle in terms of radians. So if I know this is 0, right, we would go out to pi over 3. Then we would go over here to 2 pi over 3. Pi is the same as 3 pi over 3. We would have 4 pi over 3, 5 pi over 3, and then we would be back to 6 pi over 3, which is the same as 2 pi, right? 3 goes into 6, and we can keep counting around, right? So if this is 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11, 12, 13, and we come back up here, so this is 14 pi over 3. So my reference angle, remember, is the angle made with the terminal side of that angle. So we know that this is 14 pi over 3 we can draw right here. The reference angle is made with the x-axis, and the reference angle is going to have that same denominator. So the reference angle will be pi over 3. So that's how I'm going to draw my triangle. So remember, pi over 3 is the same as 60 degrees. So remember, opposite 60 degrees is the square root of 3. If you look at our triangle that we drew over here. So opposite this would be the square root of 3. The hypotenuse is 2, which makes this 1. So also think about the signs, right? C-A-S-T. Only sign and its reciprocal are positive in the second quadrant. So that means this is going to be a negative. So this is going to be the same as the negative cosine of the reference angle pi over 3. So if I'm thinking about that, cosine is adjacent over hypotenuse, which would be 1/2. So cosine of 14 pi over 3 is the same as negative 1/2. Okay, let's try one more. Let's look at cosecant of negative 360 degrees. Okay, so just like we did, first we're going to plot it. So a negative angle is going to go this way, right? So negative 360 degrees would be here. So we are on the axis, right? This is what I would call a quadrantal angle. So I'm going to think unit circle. So the point that would be associated with that would be 1, 0. And remember, that's cosine, sine. So cosecant is the same as 1 over sine. So cosecant would be 1 over sine of negative 360 would be 0. And again, that is undefined. Okay, so we're going to stop there and let you try some problems, and hopefully that helps.